In this video, we're going to focus on polygons. So let's go over some examples. A three-sided polygon is known as a triangle. That's the first one you need to know. A four-sided polygon is known as a quadrilateral. Now there's different types of quadrilaterals that you need to be familiar with. So let me give you a few of them. So this is another four-sided polygon, and this particular quadrilateral is known as a square. In a square, all sides are congruent, and also the angles are congruent. They're all equal to 90 degrees. Now, what are some other quadrilaterals that you can think of? Another one is a rectangle. So in a rectangle, all angles are the same. They're all equal to 90 degrees. And opposite sides are congruent. So not all four sides are the same, but the opposite sides are equal to each other. So that's a rectangle. It's another example of a quadrilateral or a four-sided polygon. Another example is a trapezoid. So this right here is a trapezoid. These two lines are parallel to each other. And if it's an isosceles trapezoid, then these two sides are congruent to each other. Now, what are some other shapes that you could think of? Another shape is a rhombus. A rhombus is also a polygon. In a rhombus, all sides are congruent to each other like a square, but the angles are not all congruent to each other. Opposite angles are congruent to each other, and the diagonals of a rhombus bisect each other at 90 degrees. So that's a rhombus. Now let's move on to a five-sided figure. What do you think the name of a five-sided polygon is? What would you say? A five-sided polygon is known as a pentagon. Now what about a six-sided polygon? How can we call that? What's the name for that? A six-sided polygon is called a hexagon. What about seven? What's the name for a seven-sided figure? So in this case, we have seven sides. 1, 2, 3, 4, 5, 6, 7. A seven-sided figure is known as a heptagon. Now some other ones you need to be familiar with. If you have 8, this is an octagon. And you could draw it this way. So that's an 8-sided figure. And then for 9, it's a nonagon. And 10 represents a decagon. So those are some polygons that you want to keep in mind. Consider these two figures. Which one is a regular polygon and which one is not a regular polygon? A regular polygon has congruent sides. All sides are the same and all angles are equal to each other. So for the polygon on the left, if we call this side A and side B, we can see that side A is a lot longer than side B. But for the polygon on the right, all sides are congruent, which makes it an equilateral triangle. And also, all of the angles are congruent as well. So this will be considered a regular polygon. So here's another example. Which one would you consider? Actually, let me draw a different picture. Which one is a regular polygon? So clearly we can see that the square on the left is a regular polygon. All sides are congruent. On the right, we can see that this side is different from that side. So this would be considered a regular polygon. Now let's talk about how to identify if a figure is a polygon. So what are some characteristics of polygons? Polygons are two-dimensional figures, which means that they're flat as a pancake. Also, they're closed figures, they're not open, and they don't have any crossing lines. They don't have lines that intersect each other, and they consist of straight line segments. So keeping these rules in mind, is this a polygon? What would you say? The answer is yes. It consists only of segments, it's a two-dimensional shape, and we have no lines intersecting. Now what about this? Is this a polygon? The answer is no, because notice that we have this side, it's open, and a polygon is a closed figure. It's not an open figure. So now what about this one? Is that a polygon? The answer is yes. It's a closed figure, it's two-dimensional, and it consists of segments. What about a circle? A circle is not a polygon because there are no sides. It doesn't consist of straight segments. It's a curved figure. Curved figures are not polygons. So what about a star? Is that a polygon? The answer is yes. It's a two-dimensional figure consisting of segments, and it's a closed figure. Now what about an object that looks like this? Is that a polygon? And the answer is no, it's not. And the reason is due to this curved side that we have here. It's not a straight line segment, and so that makes it not a polygon. So let's say if we have something that looks like this. Is that a polygon? The answer for this one is no as well. You can see that this section here, it's curved. It's not straight. What about this figure? Is that a polygon? The answer is yes. We have straight segments, it's a closed figure, and it's a two-dimensional shape. What about this figure? Is that a polygon? Now the answer for this is no, because notice that the lines intersect at that point, and so this is not a polygon. What about this one? Now this is similar to the last example. We have intersecting lines, and also this side is open, it's not closed. So this is not going to be a polygon. So what about this object? Is this a polygon? What would you say? So there we have a rectangular prism. And what if we have, let's say, a cube? Which is basically, they're both three-dimensional shapes. Both of these are not polygons. Because they have a three-dimensional shape, it disqualifies them as a polygon. A polygon has to have a two-dimensional shape. And so it can't be a three-dimensional figure like a cube or a sphere or something like that. Now let's talk about the sum of the interior angles of a polygon. So the formula that you need to know is this: 180 times n minus 2 is equal to the sum of the interior angles of a polygon. So let's start with a triangle. A triangle is a three-sided figure, so n is 1. So the sum of all the interior angles is going to be 180 times 3 minus 2. 3 minus 2 is 1. 1 times 180 is 180. So the sum of all three angles of a triangle is 180. So knowing that, let's say if this side is 50 degrees and this side is 60, what's the missing side? What's the value of x? Well, we know that 50 plus 60 plus x has to add up to 180. And 50 plus 60 is 110. and x is going to be 180 minus 110, so the missing angle has to be 70. So for a triangle, the three angles inside of a triangle must add to 180 degrees. Now what if we have, let's say, a four-sided figure, like a quadrilateral? What is the sum of all of the interior angles? So the sum is going to be 180 times n minus 2. So that's going to be 180 times 4 minus 2, because this is a four-sided figure. And 4 minus 2 is 2, so 180 times 2 is 360. So for a quadrilateral, the sum of all four angles is 360 degrees. Now what about a five-sided figure, like a pentagon? What is the sum of all of the interior angles? So it's going to be 180, and since there's 5 sides, it's going to be 5 minus 2. Now 5 minus 2 is 3, and 180 times 3 is 540. So let's put this together. So for a triangle, the sum of the three angles is 180 degrees. For a quadrilateral, the sum of the four interior angles is 360 degrees. Now for a pentagon, the sum is 540 degrees. Do you see a pattern? So what if we have, let's say, a hexagon? What's the sum of the interior angles? And what about, let's say, a heptagon? What will be the sum then? And also, what about for an octagon? So notice that it's increasing by 180. So 540 plus 180, that's 720. So that's going to be the sum of all the interior angles for a hexagon. And then if you add 180 to 720, that's 900. So for an octagon, I mean not an octagon, but a heptagon, it's 900 degrees for that. And for octagon, it's going to be 1080 degrees. Now you could confirm this. You can type in 180 times 8 minus 2, or 180 times 6 for an octagon. So 180 times 6 will give us 1080. So that's the sum of the interior angles for these types of figures. Now let's work on a practice problem. So this is not a regular polygon, so keep that in mind. Now let's say that this is equal to 12x plus 2. Let's call this angle A. And let's say this is B, C, and angle D. Let's say that angle B is 9x minus 1. Angle C is 10x plus 15. And angle D is 7x plus 2. So what is the measure of angle B? So feel free to pause the video and try this problem. So using what you know, find the measure of angle B. In order to do that, we need to find the value of x first. So how can we calculate the value of x? Now, if you recall, what is the sum of a four-sided figure? What is the sum of the interior angles of a quadrilateral? The sum is 360. It's 180 times n minus 2, where in this example n is 4 since we have a four-sided figure. So 180 times 2 is 360. So therefore, what that tells us is that the measure of angle A plus the measure of angle B plus angle C and plus the measure of angle D, all of these have to add up to 360. So we could say that 12x plus 2 plus 9x minus 1 plus 10x plus 15 plus 7x plus 2, all of these, they have to add up to 360 degrees. So let's combine like terms. 12x plus 9x is 21x. 21x plus 10x is 31x. And 31x plus 7x is 38x. 2 minus 1 is 1. 1 plus 15 is 16. 16 plus 2 is 18. So what we need to do now is subtract both sides by 18. Now 360 minus 18. 360 minus 10 is 350. And if you take away 8 from that, 350 minus 8, that's going to be 342. So now let's divide both sides by 38. 342 divided by 38 is 9. So now that we have the value of x, we can calculate the measure of any angle that we want. So our goal is to find the measure of angle B. And angle B is 9x minus 1. And x itself is 9. So 9 times 9 is 81. 81 minus 1 is 80. And so this is the measure of angle B. It's 80 degrees. Now let's say we have a regular pentagon. My drawing is not perfect, but let's just go with it. What is the measure of each interior angle of a regular pentagon? So if we have a regular pentagon, that means all sides are congruent and the measure of each angle has to be the same. So we know that the total interior angle is 180 times n minus 2. That's the sum of all of the interior angles. And since each angle is the same, to find the measure of each of those angles, there's 5 of them, we simply have to divide by n. So this will give you the measure of the interior angle if you have a regular pentagon, or a regular polygon for that matter, if all sides are the same. If you don't have a regular polygon, this is not going to work. So in this case, it's going to be 180 times 5 minus 2 divided by 5. So 5 minus 2 is 3. And 180 times 3 is 540. So 540 is the sum of all 5 angles. So to find the measure of each interior angle, we simply need to divide it by 5. Now 500 divided by 5 is 100. 40 divided by 5 is 8. So the measure of each interior angle is going to be 108 degrees. And so that's the formula to calculate the measure of each interior angle for a regular polygon. So let's work out another example. Let's say if we have a regular hexagon. Calculate the measure of each interior angle in this figure. So each interior angle is going to equal 180 times n minus 2, but we have a 6-sided figure divided by n. So first we could do 180 divided by 6 if you want to. 180 divided by 6 is 30, and then 6 minus 2 is 4. Now 3 times 4 is 12, so 30 times 4 is 120. We just have to add the 0. So that's the measure of each interior angle of a regular hexagon. Now there's one more topic that I like to discuss before I conclude this video, and that is calculating the measure of an exterior angle. So we're going to call the exterior angle x, which is this angle here. If we have a regular hexagon, what is the measure of the exterior angle? So we know that each interior angle is 120. And to find the measure of the exterior angle, it's simply going to be 180 minus the interior angle, which is 120. And as you can see, these two angles form a linear pair, so they have to add up to 180. So in this example, it's 60 degrees. Now another way in which you could calculate the measure of an exterior angle for a regular polygon is you can use this equation. The exterior angle is going to be 360 divided by n. So for a hexagon, we have a 6-sided figure. So 360 divided by 60 is, 360 divided by 6, that's 60. And as we can see, it's the same answer as what we have there. So let's say if we have a regular polygon, a 3-sided figure, what is the measure of the exterior angle? Now we know that a triangle adds up to 180. That's the sum of all the interior angles of a triangle. And so to find the measure of the interior angle, it's going to be 180 divided by 3. So each angle will be 60 if we have a regular triangle, such that all three sides are the same. So the exterior angle is going to be 180 minus 60, which in this example is 120. Or we can use this formula, 360 divided by n. So 360 divided by 3 is 120. And so you have two ways in which you can determine the measure of an exterior angle. So let's try one more example. Let's focus on the octagon. Go ahead and determine the measure of the interior angle and the exterior angle of a regular octagon. So let's first calculate the interior angle. It's going to be 180 times n minus 2 divided by n. So we have an 8-sided figure, and 8 minus 2 is 6. Now 180 times 6 is 1080. So that's the sum of all of the interior angles, and then we just got to divide that by 8. And so each interior angle should be 135 degrees. So now to calculate the exterior angle, it's going to be 180 minus 135. And that's 45. Now let's confirm this answer using that other formula. So the exterior angle is also equal to 360 divided by n. So that should be 360 divided by 8, since we have an 8-sided figure. And 360 divided by 8 is indeed 45, which confirms this answer. And so that's all I got for polygons. Hopefully it gave you a good understanding of it. So thanks for watching this video and have a good day.